Real quick, just in case some of you guys are like, I don't know, even if you didn't watch the video or if you did at some point today, you may be like, why are we doing this? Number one, you guys can tell how the systems got harder, right? Section 7.3, how are they getting harder?
There's three.
We have x's and y's and z's. Yeah, so we've gone from two-dimensional to three-dimensional, x's and y's and z's. So number one, it's harder. Number two, some of you are going to be like, psh, give me a system and I'll figure it out myself. In the sense of, you're like, okay, well, I'm going to, I don't know, get rid of z's, and then I'm going to get rid of x's, and then I'm going to figure this out. And then, anyway, some of you would have a very different way of going about this problem. But the dilemma is, I mentioned yesterday just really quickly, technology is kind of the thing that our culture, our society is using these days, right? Wow, that was very anticlimactic. Technology, it's a pretty big thing, yeah? Okay. Technology, you guys even deal with it with your calculators, right? And your phones. Haven't there been times where you're like, I could just fill in the blank and do this so much easier than my teacher's asking?
Yeah.
Whether it's math, whether it's like a paper, whether it's like doing research, trying to figure something out, you're like, psh, I could make this or I could do this so much more quickly. And you might think like, this is pointless, this is useless. Some of you might feel that at some points during this section, and especially next chapter in chapter 8. But here's the dealio. With these types of problems, I could just do like 20 different examples. It would take a few class periods, but 20 different examples. And we just go through 20 different ones. And every single time we say, okay, it's a new problem. Cool. What's the easiest way to do it? And if I said what's the easiest way to do it, guess how many different ways, since we have a class of, I don't know, around like 25, I think. If I asked for what's the easiest way, how many different ways do you think I might get? A lot. Let me just show you a quick precursor. We might have some people being like, hey, let's get rid of the x's. But if we get rid of the x's, we still have y's and z's. So we've got to get rid of the x's somewhere else with y's and z's, which is exactly what I did here. I got rid of the x's with these two, got rid of the x's with these two after multiplying by 2 and eliminating. You can kind of see it over there. I got rid of the x's, and the x's had y's and z's. Let's go. Someone else, though, might have been like, hey, let's get rid of the x's. No, let's get rid of the y's instead. Get rid of the y's, get rid of the y's, have the x's and z's, then go. Someone else might be like, let's get rid of the z's. Someone else might say, hey, let's just solve for x and substitute into both the other ones. Or someone else might say, let's solve for y and substitute. Someone else might say, let's solve for z. And depending on the system, maybe random student number 10's way is going to be easier than random student number 2's way. Now there's maybe random student number 10 is going to pick a different way for every single problem based on wherever maybe the 1 is in the problem. Like this one, solve for x. And the next problem, when z has a 1, ooh, let's solve for z. And the next one, where something easily cancels, hey, let's go ahead and get rid of stuff. The dilemma is, if the system or if the way of solving is changing every single time, I want you to pretend to think like a computer programmer just for a second, not in knowing how all the coding or all the different languages or all that sort of stuff works. But just the idea of a programmer. If someone was trying to program, we have technology, right? To make a program to do the work of this math, what would you need to be able to make that program? A different way for every single different problem depending on what it looks like? No. You need some sort of systematic approach to say, do this, do this, do this every single time to get to this, right? You can't just say, hey, Mr. Computer, look at the problem and figure out what the easiest way is and let me give you 10 different ways and you just go for whichever one looks good. That's going to be a horrible solution, right? If you were trying to program or make a program or somehow use technology in order to be a convenience or in order to fulfill or to meet or to do a task, but you're like, oh, this is kind of menial, I could get a computer to do it. You have to figure out some sort of systematic approach that's like, okay, this will work every single time that it's possible. Now, pause. In substitution and elimination, did we realize some systems are impossible to solve? What's that word for impossible to solve? Extraneous is one of those where the math says it is one thing and it doesn't really work. So that would be another way. If the only solutions were extraneous, it'd be inconsistent also. But inconsistent is like, you gave me a system, but there are no intersections. Or there are no intersections of all three. Either there are no intersections, they're all parallel, or there are no intersections where all three, you guys see there's like a hole in the middle? It's like a little tent if I was to move it up, there's a hole in the middle, there's no place where all three planes would intersect. There's a couple different ways inconsistent solutions could, or systems could be occurring in a three-dimensional system, since we have three things now. And consistent, there could be just one answer, or there could be infinitely many, like all along a line, or it could be, here's the equivalent. This very last one, go ahead and write equivalent. Or it could be equivalent where all three of the systems, all three of the equations are all the same plane. That's very, very, very rare. Usually if it's consistent, infinitely many, it will be this solution here. And that's kind of like last section when we had a true statement. We could say that there are infinitely many solutions. We could say that they're equivalent, but we could write down what the solutions are by giving the line, y equals mx plus b. Anyway, we'll get back to that in a second. The idea of this section is not like, hey, how creative are you? Go, little human, look at the problem and try to figure out. This is the easiest way for this one problem. Great. I'm glad you were able to do one, but how about all the rest? And what if you wanted to one day not just be the one using the technology, but maybe making the technology? You can't just think of one way to solve one problem, the easiest that you can. You have to think of the whole category of problem and say, okay, what would be the system that would solve it everything? Does that kind of make sense? The difference in thinking? Do you guys look at our world today and look at technology and say, oh, hey, it's kind of important to actually think about the general category solving instead of one simple problem on one simple homework in one simple class? Yeah. Makes sense, the difference? Okay. How easy is it, as though, to zoom in on the one assignment, the one homework problem, the one, how easy is it to zoom in on that and say, oh, I just want to do the easiest I can and then be done with it? Right? It takes, I don't know, it takes character, it takes maybe an ability to forward think, to look at the bigger picture. That's hard. It's hard, especially in high school, to step out and be like, hey, there's more going on here than just this one thing that I'm complaining about. So, in homework, when you're like, it'd be easier to do this. I'm not saying that you can't. I'm just saying I'm trying to have you step out of the one problem and think instead of the entire category and say it'd be a lot cooler, not just to be able to solve one, but to be able to solve them all. And maybe to be able to program something to solve it for me. But it takes a lot more work to figure this out than just to figure the one out. Does that make sense? Okay. So anyway, this problem that we did yesterday, once again, the system, just in case you weren't able to watch it, just really quickly. Our system is the following. First of all, row echelon form is a snazzy stair-step form. But if you watch the video, we talked about how we'd much rather have an equation looking like this or this. They're both stair-steps. They're both row echelon forms. I know they look different, but they both get us to the exact same final solution. And the reason why we're like, it's so much better to have this form than that form is because, guys, who do we already know in this form?
Z.
And if you know Z, what can you do? And if you know Y and Z, what can you do? I love the stair-step. I love the row echelon form. Makes things so simple. But you're going to be given something nasty, and we're just saying that would be so much nicer. Is there a systematic way to always get there? And the answer is yes, as long as it's possible. To always get there, our system is going to be, trying to think like a programmer, this will work every single time. Take the first two, add them. Wait, would that work every single time to get rid of the x's? No. So even though we were kind of, and I told the kids yesterday, you can be little humans and be like, hey, let's just add it. Okay, the system is take the first two and get rid of the x's, take the second two and get rid of the x's. That's the system. But we're little humans, so let's not make it harder than it has to be. Let's just add, let's multiply by 2 and add. But the idea is if you were a programmer, you'd say, well, wait, what if that was a 7 and that was a 3? How do I get rid of the x's? What if that was a negative 7, that was a positive 3? You would multiply the top one by that number, multiply the bottom one by that number, and throw in an opposite sign somewhere. Whatever the coefficients were, if you multiply the top one by the second number, or coefficient, and the bottom one by the first number, and make one of their signs opposite, it will always cancel. So we didn't necessarily go through all of that, and actually how you would need to, well, we're not doing coding at all, but we didn't go through all of that. But the idea is you could, pretty quickly, be able to say, always take the first two, get rid of the x's, always take the second two, get rid of the x's. And what happened when we got rid of the x's? I only have two variables left. So if I only have two variables left, even though these ones were super nice in that it was a 1 and a 1, if it wasn't a 1 and a 1, if it was a 5 and a 4, okay, whatever. Once again, you'd multiply that by that, you'd multiply the second one by that coefficient, put an opposite sign somewhere, they would always cancel. But we were humans and we said, no big deal, let's just subtract. Multiplied everything by a -1. Now what do we got? Z equals 2. And now that z equals 2, we're like, sweet, let's steal one of these guys, and let's go ahead and steal one of those guys. The row echelon form says, leading coefficients of 1, show me the stair step, and then just finish the problem. Done. And that system will always work as long as it's possible to be solved first.
I remember yesterday in the video when you said we can use use a matrix to find the row echelon form.
I said that the calculator can do it. Let's try to figure out how it was programmed. But I think I also said, I don't know if I said it quickly, this test will have a calculator and non-calculator portion.
But my main thing was on the one it gave right there. Instead of 17, it gave me 8.5.
Did I not divide it correctly? Ooh, thanks, Chris. You found my typo. Or my write-up. Good call. Those of you guys that have these notes written down, can you double check? 17 makes no sense, and why? Did you notice yesterday when I was saying, or we will notice soon, the calculator spit out this one. You'll have to watch the video yesterday to figure out how the calculator does it. The calculator spit us out this one, and I was like, it's different than the one that we used, but it actually still got us to the exact same solution. We checked it. Do you remember where I said the calculator programmers seem to always get the first equation? If you do more of these, you'll see it. From the last. For some reason, the programmer decided to make this last one always the first one. Now guys, little humans looking at this problem says, that one's 1. He's easy to put first. The computer doesn't know, so the programmer told him, always take this one. It was like, fine, I just personified the computer. Anyway, told it to always take the bottom one. But the row echelon form says, I need a leading coefficient of 1. So how do you get rid of the 2? Divide. Divide by 2, divide by 2, divide by 2. What did I forget?
Divide by 2.
Oh, struggle. Even I killed a seal.
Can you explain the first step of getting Z? Like you got...
Well, it's not the first step. It's actually the third step. Well, kind of the fourth step. I grouped these two and did what I needed to from elimination to get rid of x's. I grouped these two, did what I needed to do, multiplied by 2 to get rid of the x's. Then I did little eliminations, added down. Little eliminations, added down. Then I went ahead and did what I needed to do to get the y's to cancel. I have z equals. Yeah.
Why would you divide by 2?
Oh, because row echelon form, you need to watch the video yesterday maybe, I need leading coefficients of 1. And so the calculator program was made in order to say, hey, the first equation, always take the last guy. I don't know why. We didn't do it when we did, because we're like, that one's easier to use. But the program said, always take this one, but it needed a leading coefficient of 1, so the program tells it to take whatever coefficient is here and divide everybody by it. That way you'll always get that leading one.
Wait, is that a different way to solve it?
This is how we as humans solved it. This is what the calculator solved. And both of them lead to the same exact solution. Okay, that leads us up to 7.3a. 7.3, I don't think we have time for him. We might come back to him. 7.3b. Oh, I have it written down. Let's get rid of this page. He's randomly there for no reason. Okay. 7.3b. Just keep it 7.3 in your notes. Don't make a new section. I'm just letting you know now we're getting to the tricky ones. Now we're getting to the tricky ones. Kiddos, if you did do 7.3 homework, I believe you might have had a little bit of a dilemma. It's in the 30s. Did they get there? 30, 31, 32?
Yeah.
Is this a homework problem? I might have actually written it down. Oh, 37. In the 30s, you got to a weird problem. In the 30s, you got to a weird problem. Let me give you guys a second to write down this system. Actually, Chris, I'm taking back my previous comment. I'm not exactly sure I said yesterday there's a non-calculator portion per se, but I did say there's at least one or two where you have to show the by hand work to get the RDF point. That's a better way of putting it, what might be coming on the test. Once again, if you guys want to see how your calculator can help you double check, remember I just said we gotta be able to do this by hand at least somewhere. I'm gonna check out that video from yesterday. Right now I am doing the calculator work just because I'm making sure this is one of the weird ones, I think it is. But the cool thing is with the calculator, you kind of double check, like say on the evens, you can double check you did it right if you figure out how to do that math. If your calculator shows you nasty decimals, if the calculator ever shows you nasty decimals, you can use that cool fraction button to make it pretty. This is not a nasty problem. It's actually a pretty straightforward problem. I might not solve this all the way, but can we go ahead and just practice the system real quick? We need to make sure we get to one of the tricky examples to help you guys out. Let's go ahead and, let's go ahead and follow the system. So for those of you that were here, or for those of you guys that watched the video, the system would say, what do we do? Okay, somehow get the first two x's to eliminate. And then get the second two x's to eliminate. Okay? We're little humans, so we're not gonna, we're humans. I don't know where the little came from. Oh, I hung out with little people yesterday, sorry. No, little like elementary kids, sorry, take it back. We're humans. Shh. Okay, good. It's okay, God made me just the way I am. There are pros and cons to both. Anyway, coming back. We're human. So let's go ahead and just say, how will we make the two x's eliminate? Multiply by a -1, right? So I'm going to go ahead and multiply by a -1. Hey, it's not totally bad if I just do it now, because I think I might want a negative for this guy too, right? So let's go ahead and, I rewrite it, guys, because you saw me yesterday, I made a seal mistake. And that was with having like at least 10 kids here to double check me. So it's going to be really easy to make mistakes on these, because of all the numbers involved. Not that it's hard math per se, I don't really think it is, but just better safe than sorry. 1 minus 6, 3 minus 8. Double check me and stop me if anything doesn't match up with what you did or what you're doing, okay? But I think I got -5y minus 5z equals -2. Good? Cool. Next one, I'm going to multiply this guy by 3, is that all right?
Yeah.
Now, if I was a computer, I would have this guy multiplied by 6, this guy multiplied by 2, and put a negative in one of those. It'll always cancel. But since I'm human, let's just multiply him by 3. So I'm going to get -6x by 3, -18y by 3, -24z by 3, -9. I don't know about you, but sometimes I have to remind myself of what I'm doing as I'm doing it. Especially if I'm talking and trying to explain stuff. Multitasking is dangerous. Okay. Don't text and drive. -18 plus 8 is -10y, right? And then -6z, and then -4. Oh, good? Okay. It's time for me to keep going, but I can't keep going quite yet, right? What do I want to happen in this next round? Yeah, I want to somehow get something to cancel, and hopefully, according to our system, let's get the y's to cancel every time. So the y's to cancel, what do you guys think multiplying this guy by -2? Does that look good? So I'm going to get, now I just rewrite it to be safe, I get 10y plus 10z equals 4. And I have -10y minus 6z equals -4. At which point I get 4z equals 0. Ooh. Which means z equals, it's allowed to be 0. It's kind of weird that it's 0, but alright. Now, if they were asking row echelon form first, they want the stair step. Since I'm a human, I might go taking this guy as the stair step for the first equation or that guy, but what did we say our calculators use, just so that we can check it with the calculator? The last one. Now for all of these, none of them is easier than another because my row echelon form needs leading coefficients of 1, so what would I have to do for all of them this time? Divide. Divide by 2, divide by 2, divide by 6. We're going to try to match up with the calculator, so dividing by 6, I'm going to get 1x plus, what's 8 over 6? 4/3 y, right? Plus 18 over 6 is going to be 3z equals, I'm not going to make the same mistake twice, huh? Next, 5/3. Divide everybody by 3. Now, what do I need next in my stair-step system? An equation without an x. I need to step down. 5/6. Thank you. I got too busy not repeating my mistake, and then I made another mistake. Go team. You guys ever focus too much on one thing and then you mess up on something else?
That was just me right now.
Okay, I need the next line.
Should you use the bottom?
Well, I was going to say, let's get another equation. The other equation needs no x, so I go to these guys. I need to divide by either one, and if you guys notice in the last example, the computer or the calculator program chose the bottom one. So if we divide the bottom one by -10, it would end up with, divided by -10 is a 1y. -6 over -10 will be plus 3/5 z. Equals, and then 4 over 10 is going to end up being 2/5. P.S. If anybody learned how to do this in a calculator yesterday, can we plug this guy in, do REF, and let's see if it matches?
Yes.
Last line, z equals 0. As somebody checks in the calculator to make sure that we have the proper REF form, we're going to go ahead and say, hey, why was the stair step so awesome anyway? We know one of them, and we can easily find the other two, right? We know z is 0. We can plug in 0 to get y, which I believe will be 2/5. Double check my math. Plugging in 2/5 and 0. 0 will be 0, 2/5. Okay, hold on. 8/15. So x is going to equal 5/6 minus 8/15. Okay, get common denominators. Let's multiply. 3 goes into both. Okay, we can do 30, right? To get 30ths, that'd be 25/30ths minus 30ths, that'd be 16, which would end up being 9/30ths, which reduces to 3/10. Now, those of you guys, if you've done it in your calculator, you should have 1.33333, that's really nasty.
Yes.
Go to math, the math button, see the little arrow with for fraction?
Yes.
Hit that, hit enter, all of a sudden your matrix is pretty.
If you're using the human way instead, what would you put into the Are you using the way?
What would you do with 0?
Yeah, what would
You would plug it in.
What about you do another way? The right.
Oh, I see what you're saying. I mean, if you didn't do the calculator way, you might have chosen this guy for the first, you would have just divided everybody by 2, so it would just look differently, or the numbers would be different. But you would divide everybody by 2, and then maybe this one, divide everybody by -5, so you would have different numbers, but it should end up in the same solution. Does that make sense? Okay.
You can't plug in the z into the top right formula and get y.
You can. We just chose one, and we saw what the calculator chooses, in the sense that the calculator always chooses this one to go there, and this one to go there. So if we wanted to check that we had done it right, if we did the other guy, and if we did another one, we just wouldn't be able to check with the calculator before solving whether or not we were on the right track. Does that make sense? So we're just trying to kind of follow the programmer, whatever reason he chose the second one and the bottom one. We're just saying, hey, if you want to check it with the calculator,